Good afternoon, everybody. How are you today?
Doing great, thank you.
Yes. But before our presentation, I would like to thank you, our customer and advisor, Dr. Abdullah Omaifa, and our great support and help from Alan and Sonia. So thank you for you guys for helping us and give us advisor so that we can come up with a presentation today. I would like to introduce you today our team, C.A.R.S, a creative assisted robotic system. Our team leader, Josh White, he's also the spokesperson and a circus designer. Our recorder, Kaya Vaidia, is also a simulation developer. And our analyst, pessimist, Clarence Hauser, he also the programmer. And I am T-Lay, I am the optimist and analog designer. Our team project is tracking of driver eye movement. And this is our abstract for the project. First, we try and we want to design and implement the eye tracking system to monitor the driver on a SimVista driving simulator. And then the system will predict the driver distraction level based on the eye movement data. And after that, the system should be can use to lock and monitor each driver and give the warning when there is a distraction. The system also should be intelligent, non-invasive, and accurate. About our presentation, we're going to have the hardware and software components, level 1 design schematics, and other system circuits design. We also have a breakdown structure and a cost summary. So for the hardware and software component, I would like to introduce to Josh, please.
Thank you, T. Our hardware for this project is the Gaze Point GP3 mounted eye tracker. As you see here, it uses sensors within there to determine the gaze detection and the pupil of the subject, whoever's going to be driving in this case. Has a 5-point or 9-point calibration. And we're also going to be using the Arduino Uno microcontroller for our alert system to send in inputs and get out outputs through our displays and our visual and audible displays. This is our functional block diagram. As you see, we have our sensing systems that are going to talk to our distraction level system. We'll be collecting all of the data from our simulations of the eye tracking and then output through the alert system. That'll be audible and visual, and we'll also be able to model driver behavior based on their movements and where they're looking at. This is our current alert schematic that me and T came up with for our analog portion of our project. We have 2 potentiometers here to monitor the backlight and contrast of the LCD display. And what we're going to show you later is, in our demonstration, is how we're displaying that the drivers become distracted and it scrolls across the screen.
So basically, as being the programmer, I did the code for the Arduino board that actually displays the words on the LCD. The only thing that we have to get now is to try to set the components for when it's actually distracted, because right now it's just displaying the message. It's not really actually picking up whether they're distracted or not. It's just showing that it works. So all we have to do is add a couple components to actually pull out the data from the text file that the program gives, and then it will determine whether they were actually distracted or not. So then it alerts them then. But as of right now, it just displays the message by itself as how the circuit is built.
And we're also going to add a buzzer that we have in the senior design lab for when the driver becomes distracted. So we'll make a buzzing sound as well as display this LCD for our warning system.
That way it's not too distracted, but it's a warning that they can get their ear versus actually being so loud to the point where it distracts the people.
What would it be nice if you have the schematic of this connection? Huh? Yeah, this is what it,
This is just the circuit I showed you on the, it's not a circuit diagram.
this is the, you should really show us the circuit diagram, how it works.
Yeah.
I know you put things together. This is what it is. This is the real system. But before you go to the real system, you should have what the schematic.
Okay.
Well,
And this is our breakdown structure of what we have done so far. We have, of course, purchased our product, as you saw in the earlier slides, where we got our tracker already. We have connected the eye tracker with the simulator, and we have actually tested it out with using it to where while you're actually driving, it actually pinpoints where the driver is looking at each time, and it gives fixation points. The blink detection is also built in with the components, so all of this we have already done so far, and all of components are already integrated together.
Yeah, so what we have left is to finish the program to read the text file that the sensor, so the sensor takes in the eye readings based on like fixation points. So each point is plotted in this notepad file. And the text file is what we're going to read in, and based on those coordinates we can see when the, like for example, if I'm driving on the simulator, if I'm looking off of the center screen, because that's the forward roadway for our case. So if I'm looking away from that forward roadway and it goes out of the screen for a certain amount of time, that's when we can determine that the driver has been distracted. So we had some papers that we read from, like Donald Fisher and some other collaborative people had some papers. They determined that 2 seconds is the safest allowable time. And they also, in their papers, they showed that anything under 5 seconds is safe, but 2 seconds is the safest. And they said, because that's where they're least distracted. 4 seconds is not as safe, but they can detect more hazards if they take more time. So in our constraints, we wanted to have like an ability for being able to adjust the alarm system so that if like a sensitivity adjustment, so we can use that like between 2 and 4 seconds to adjust that and have that sensitivity for that time. And also, we still need to figure out how to get the sensor and the simulator and the program to work at the same time. But right now, all we can do is just export the data after we recorded a session. It's not working at the same time, so time is where basically where we have the issue. So basically, the future opportunities is integrating that system together so that if we can have everything running simultaneously, it will be more accurate, and we can have the code running while the simulator is running. If we can get everything integrated together like that, that's where we can get the data being read while you're driving, so it can alert you while you're driving. Right now, we don't know how to do that. And even other universities, they don't know how to do it yet. So.
These are our engineering specifications one more time. As far as what we expect the system to do, intelligence, accuracy, private, logical, and we've gone through most of that about the alert driver after 2 seconds or 4 seconds, log all the data, have a passcode for the data to make it private, personalized, and make sure our alerts not exceeding 45 decibels, so it wouldn't be too alarming to the driver. This is our cost summary so far. The eye tracker we got for $500, and the rest of the parts are parts that we've pieced together from the C.A.R.S Design Lab. So those haven't cost us anything so far. So the Arduino, the LCD, and the buzzer, and the breadboard are all leftover parts.
So, like I already talked earlier, we're gonna try to do an analog circuit diagram for the other system to be completed. And right now we are done the coding for the other system circuits. So we're gonna try to finish that to implement the audio and visual other system one. The traction level design will be implemented alongside the eye tracker and driver behavior collector after we get all the data grouping together.
And we expect to be done by around March 1st, just so that we can have April 1st, so that we can have that extra time to tweak anything that we need in our project, or however, anything you guys want to add on. We have time to do that.
Okay, then let me ask a question. I don't know whether I heard it right, or maybe somebody mentioned that you have connected the eye tracker to the system,
Yes.
to the simulator.
Yeah.
No, not to the simulator. We have it on the computer, but we can't run it with the simulator yet at the same time. It's not like a component actually attached to the simulator.
Oh, so what you have?
But we,
What it does is you can have it running while you're driving the simulator, so it knows where you're looking at on the screen. So like when we go back to replay the video, it shows the simulation of the road, and it shows you the points for each little spot on the screen.
Yeah.
So it's not completely integrated with the simulator, but it's on there where you can see where you looked at on the road. It's just not completely integrated yet.
they're running, but it's running independently from each other.
Yeah.
So that's the
We can show you. We have
Okay,
a video.
Actually have
of
the-
okay, why not?
Actually, I have the video here.
Didn't you put it in here already?
The flash time not doing it. Is it the bottom? Close enough.
What's that?
No, that's the-
Oh,
Question first. Okay, so so this is an example of like data points that gets exported from the eye sensor software. So this
So what is all this?
This basically what we're looking at is we have the time in seconds, like how each time step, and then these two, this x and y coordinates. These are the ones that we're looking at. That shows you each coordinate according to the screen. And so I can play this video. It shows like kind of how the fixation points look while you're driving. So this is like in the screenshot mode. Basically all of these points is like fixation points that it takes like every like 0.2 seconds where your eyes are stopped at for that much, for like a longer time. So you know like this so and then up there in the corner you can see that like T is driving there. You can see his each individual eye in the corner and then his face there. And so like this is it, him driving all these points. Basically, at one point, I don't know, like probably halfway in the video, he looks outside of the screen, and you can see that point will go out, and we have these.
Set the boundaries so that you can see where he looked off in the show.
So these boundaries, we have like an area of interest there, so that when it goes out, we can pull that data separately for each area of interest to kind of find where.
Well, it seems to me that you are even changing the lane. You're driving the other side of the two-lane. Is that right?
Yeah, right now,
That's
yeah.
just-
Right now, you hit something now.
They are going through the vehicles
Yeah.
and content.
God, no. Yeah, sometimes, what happened? And what is that one? Yeah, I was looking at another screen. This is nice, but
Yeah, so we were just
We can try to see how
we were just like doing a test run just to see how the sensor works.
how the sensor.
okay. What is right now? What is it that
So right
That is
now,
before the simulator starts up.
what is it that just pause it right there?
so see right now
Before the
this is
simulator starts up, so it's still showing where he's looking on the screen, but the simulator hasn't started yet, but it's still collecting that data. And that's what we're trying to get him right at the same time, that we don't have any delays, that's when it
It's not
starts.
integrated like we wanted to do when we contact them. If we integrate it that way, then the eye tracking only starts when
When
the driving starts.
Yeah,
But in this case, as soon as they start the program for the eye tracking,
it's
whether it is driving or not, it already sees where you are looking. It already starts monitoring you. So it starts
Yeah.
giving the features from them.
So then why don't you just let them start first and then you turn it on?
So that is how
well,
eventually we have to do it.
You know-
It's safer to allow it to start before the
before,
so they
okay.
can cut off part of that.
Okay, no, then you should cut this thing off.
yeah, you're
Yeah.
Okay, now let's move on. There's certain thing that I want to see. Okay, there are two screens.
So there's a
It's loading right now. Yeah.
yeah, so
Okay.
the simulation.
Okay.
running.
Go.
And
It's on
then-
the screen up in the corner.
Okay, what is this now? View? Is it come from here?
Yeah.
Yeah, this is from the
Supposed to start.
And then, okay.
simulation.
Okay. Now you see the way that it looks to me, you are driving in the other side of the street.
He created the scenario, so the starting point he gave for the car,
Yeah,
was,
it
he
just started
didn't
in the middle.
place it
Yeah.
very well, so the car was slightly in the other lane.
See, now okay. It
But
seems to
eventually
me
they will get into the lane.
we have that invisible car that is going through the other incoming car. Now we have okay.
Yes.
Okay, see, there's another car. That screen in the top.
That's
Oh,
that's the rear mirror.
Yeah.
That's the,
This is behind you.
Yeah.
So what does those triangulation means?
It's showing where he's, the outside or
Those triangulation.
it's showing where he's looking
Those
at.
are each-
Where my eye looking at on the screen.
It's where his eyes were fixed at each.
So your eyes in the car is looking at this one now? You're gonna hit this
Yeah.
car? Yeah?
yeah.
Yeah, so right now he's looking there.
We didn't have a very good driver.
Who's driving? You're driving.
I'm not used to the simulator yet, so still looking at it.
But yeah, he's looking
No, it's okay.
here. And then we told him to look
Yeah, you
off.
see off like right there.
He looked off
Yeah.
right
off.
here.
Yeah.
So they told me to look on the other side, on the right side, and that's why I hit the car.
Yeah, so basically the points we're looking for is like these kind of points. So here is like, I don't know, like 0.229 or something. We want to look for these kind of points, and that's how we determine the boundaries.
Whether he's distracted.
Basically.
Okay.
So based
Got
on
it.
the screen. Yeah.
Okay.
So when it reads in the text file, when it sees those points.
Correct. What is it that you're supposed to be doing, Mr. T? What is it that you're supposed to be doing?
I do this right here.
Digital, right?
Our system circuits given just the visual warning.
You created? Or
This one K is do the simulation developer, so he the one doing it, and I just a test driver.
so when is yours going to be ready?
We're about to
We can test that.
But this is the digital one, right? You said analog.
Well, the analog was the breadboard. Dr. Graves said that as long as we had some wiring, he would count that as an analog portion of our project.
So what is that one?
Oh, those are potentiometers. They control the backlight and the
Yeah, hold on.
contrast of the LCD,
Because it goes out. It gets,
Okay.
and it just flashes across and says you become distracted.
So right now it's always showing that there
yeah,
is
as of right now.
Yeah, that's
Right now,
our-
we just
data.
showing the
Display.
screen like that. It's,
So yeah, we still have to write the code to call that function whenever they become distracted. But that's just what it's going to look like, and then once we add the buzzer, it'll have a beeping noise to it.
right now, working next on the buzzer, so we give some sounding warning. This is a visual. The other one is audible. It's working on that.
Okay.